Welcome everyone to New South Wales DPI Dairies webinar number 3, Precision Dairy Technologies, Opportunities and Challenges. This webinar will be a bit different to the previous ones as we have the great privilege of having a top international guest speaker with us here today. Dr. Jeffrey Bewley from the University of Kentucky in the US has kindly accepted our invitation to share with you a bit of his deep knowledge on precision dairy technologies. As an introduction to our guest speaker, Dr. Bewley grew up in Kentucky and early in life got involved in dairy, working on his grandfather's farm. Dr. Bewley has a Bachelor of Animal Science from the University of Kentucky, a Master of Dairy Science from the University of Wisconsin-Madison, and a PhD from Purdue University. Currently, Dr. Bewley is a researcher at the University of Kentucky, and his main area of work focuses on precision dairy technology implementation, mastitis prevention, cow comfort, lameness prevention, and decision economics. He has numerous publications in scientific journals and industry articles and has spoken at conferences all around the world. Dr. Bewley, the stage is yours and the privilege is ours to have you with us here today.
I appreciate the invitation to present to you all this morning. It's evening here in Kentucky. Talking today about an area that I think is very exciting, all of the different technologies that are coming on board for the dairy industry, and to think about what we might be able to do with these technologies, to talk a little bit about some of the research that we've been doing here, and to discuss some of the practical implications of making these technologies work on farm. I always want to start out my presentations by thanking my graduate students, undergraduate students, and farm staff for all that they do to make the work that we do actually happen. When we think about technologies and sensors, it's nice because these technologies provide us ways for the cows to talk to us. In the past, we may have thought, I wish the cows could tell me when something was going on. And in many cases, these technologies are providing that opportunity for the cows to tell us what's going on with them on a day-to-day basis. The area that we're focused on here in our work is what we would call precision dairy monitoring. And precision dairy monitoring is looking at the milk components, the conformation or the behavior or physiology of the animal, trying to better understand what's happening with the individual cow. And one of the nice things about precision dairy monitoring is it enables us to move from just thinking about managing groups of animals or herds of animals to being able to go back to the idea of managing the individual cow. One of the questions then is, can we get to happy cows through the use of technology? And you can see a few different examples here at what's going on at the University of Kentucky. We have Precision Patty, our mascot there. She's a blue and white cow. Blue and white are our university colors. And she's wearing all the different technologies that we have here at the University of Kentucky. You can see an image analysis representing some of the image analysis work that we're doing, the wearable technologies, leg-based, neck-based, ear-based technologies that can provide us a lot of information about the behavior of the animal. The AFI lab is one example of a technology that's used in parlor to monitor milk components. And then the end result is what you see there with 510, a cow in our herd who actually has developed the smiley face on her teeth. When I look at the cow, I think about all the different possibilities of what we could measure on that cow. And there are a number of different items that we may be able to measure on cow. It's absolutely amazing to think about all the information that this cow can provide us. And many of the items that we have listed on this screen are things that in some fashion or another, if you're a dairy farmer, you're measuring or monitoring in some way or another on your farm today. Maybe not all of them do we have the ability to measure automatically or record that information, but we're at least looking for many of these parameters. Now, when I look at that list, I also start to think about a practical reality in that we probably don't want to actually measure all of those things. We can run into a trap of falling in love with the information and thinking that if we could measure this, wouldn't it be neat? And we can measure more than what we actually need. And in many cases, I think that goes into a situation where it's not economical. I think it's quite clear that if we measured all the parameters on the screen for our cows, that would not be economical to do that. And certainly I would say that even here at the University of Kentucky, because we're a research-based institution, the value of the technologies on any single one of our cows is more than the value of the actual cow. And that's not an economical scenario. And economics is something that really is absolutely key to what we're doing with these kinds of technologies. There are a lot of different potential applications of precision dairy monitoring. Estrous detection is probably the most commonly used technology. We see a lot of farmers that have invested in estrus detection systems around the world. These systems do work. They do a really nice job picking up cows in heat. We see systems that could be used for mastitis detection, for fresh cow disease detection, lameness detection, calving detection, potential for measuring and monitoring things that we could use as new genetic traits, being able to measure phenotypes that we previously might not have been able to measure, and bringing that information into our genetic evaluations so that we can actually select for traits like locomotion or body condition score. And then using this information at the pen or the herd level for managing what's going on within the herd and monitoring changes across time or compared to other operations. There are a lot of different potential precision dairy benefits. One of these, I think the one that we're the most interested in here, is improved animal health and well-being, early detection of conditions, increased efficiencies, improved product quality, minimizing the environmental impact of the dairy, and providing us more objective measures of items that we've typically measured subjectively. Things like locomotion scoring or body condition scoring that we've always done subjectively. Perhaps with technologies we can measure these things objectively and get more reliable, regularly recorded information that we can use to manage our dairy operations. When we think about disease detection, it's quite logical to think about how it may be beneficial to detect disease early. If we detect disease early, we might be able to treat the animal sooner. We can improve our prevention program, and hopefully these actions will help us improve the outcome from the treatment, reduce production losses, reduce economic losses, and improve animal well-being in our operations. Now, it's important, I think, to stop here and recognize that when we say these things, it does make a lot of sense that this could be the case, but if we actually try to quantify how much is the value of early detection, of early treatment, it's very difficult to do that, and there's not much in the literature demonstrating what the value of early disease detection actually is. If you look across the market, it's absolutely overwhelming how many different options there are. There are so many technologies that we can now use on our dairy farms. And if you're sitting on the farm today, it's a difficult question to think about, is that if you decide that it's time to invest in a technology, which technology should you invest in? I think it's really difficult to decide with so many options, so many different strengths and weaknesses of different technologies, and where they are in the development stages. What are the criteria that we should look for in a technology? Here's the criteria that I think we would look for in an ideal precision dairy monitoring technology. First of all, I think that technology has to explain an underlying biological process. It has to explain something that's going on within that animal. It has to be something that we can turn into a meaningful action. It needs to be a piece of information that not just knowing what it is, but by knowing what it is, I can make some change or action relative to a particular animal or group of animals to make a difference with that situation. The technologies have to be cost effective. It doesn't necessarily mean low cost, but we better be able to demonstrate an economic return for using that technology. The technologies have to be flexible, and they have to be robust and reliable. It's a very difficult environment that we ask these technologies to survive in. We have big, clumsy animals working in wet, dirty environments. The technologies have to be simple, and they have to be solution-focused. Too many times I see an engineering gadget that's looking for an application. But to me, I would much prefer scenarios where we have an issue on the dairy farm or an opportunity on the farm, and we find a technology that we can use to help manage that. So starting with the cow and moving toward the technology instead of starting with the technology and moving toward the cow. Lastly, I think that the technology has to provide information in a format that's relatively easy to understand, that's a simple way of combing through all that data, maybe some kind of an alert list, some kind of a dashboard that provides us the key pieces of information that we need to use within a day on our dairy operations. Let's take a look at some of the different technologies that are out there. We'll start in the parlor. One of the most exciting opportunities in precision dairy monitoring is the systems that are now coming out to do inline somatic cell count. We have multiple options now that are on the market or coming onto the market that can provide us individual somatic cell count for individual cows each milking. From a mastitis management perspective, this early detection tool I think is pretty exciting. On the other hand, I think we have to be cautious because I think there's a chance that we actually may use a technology like this to increase the number of treatments that we have. And if we increase the treatments, and that's treatments that are not necessarily needed, we would possibly increase our antibiotic use, which may have an impact on antibiotic resistance, but more importantly, we increase our dump milk, and that has a direct impact on the bottom line because that milk costs the same amount to make, but we don't get as much from it when we have to dump it. And one of the challenges is that when we're measuring this frequently, we'll actually find that there are cows that periodically spike in somatic cell count for a milking or two, and then they drop and they go back down to normal. And the tendency on that might be to treat that cow. She has a high somatic cell count, let's be proactive, let's treat her. But in many cases, this is actually just the natural reaction of a healthy cow. The cow has mounted an immune response, and she beat the infection. And this happens every day on our dairy operations, but we miss it because we're not measuring that frequently. So I think we really have to be cautious about actually over-treating with these inline somatic cell count tools. There are multiple systems now on the market that use spectroscopy, which is basically looking at the pattern of light flowing through milk, the multiple arrays of light that those would look at. It's an indirect way to look at changes in milk composition. The Appy Lab, for example, uses near infrared, and it measures fat, protein, and lactose in line. The nice thing about this kind of technology is that there are no reagents involved. There's no variable costs associated with using this technology across time. Another exciting option coming onto the market is the Deal of Out-Herd Navigator. This system measures multiple parameters in the milk. It measures progesterone, for example, which is a good measure of heat detection, can be used for pregnancy detection, can be used for detecting cows that are cycling or not cycling. It can also be used for abortion detection. Really a powerful, powerful tool for reproductive management. It goes from looking at indirect measures of estrus, for example, like activity, to a direct measure of what's going on physiologically within that animal. This technology also measures the LDH enzyme, which is an early indication of mastitis. It measures BHBA, which is an indicator of subclinic and it measures urea. The multiple parameters measured within the same system to provide us a tremendous amount of information about what's going on with that particular animal. We look at the wearable technologies. I think it's interesting to compare what's going on in the dairy industry with what's going on in the human industry. We see a wide adoption now of parameters, of technologies that we can wear ourselves to measure what's going on with our physical activities and our health. Now when I talk to people who are not in the dairy industry about what I do, it's very easy for me to describe that we work with Fitbits for cows. And these are exactly the same idea. We're using the same base technology, accelerometer technology, to measure activity in the animal. There are multiple systems in the market now that measure ear or neck-based behavior. These systems, as the name indicates, are sitting on the neck or the ear of the cow. They measure activity. They measure things like rumination time and eating time or grazing time. These technologies can provide us a tremendous amount of information about what's going on with the cow on an individual day, and I think can be very powerful tools for managing our dairy operations. We have multiple technologies that measure physiology. We may take, for example, a monitor that measures vaginal temperature. We have a technology, the fever alert there, that measures ear canal temperature, or we have multiple rumen boluses on the market that measure temperature. Each of those, unfortunately, comes with its own set of disadvantages. Vaginal temperature is a limit because we can't leave a device in the animal for a very long time without creating an infection. Rumen temperature is limited because every time a cow drinks water, there's a dramatic decrease in temperature that occurs, and it can take as much as 3 hours before that temperature returns back to normal. Therefore, there's a lot of information that's provided that's not really representative of core body temperature. A system like the fever alert there is a great concept. We can get a temperature that goes into the ear canal. We get to a tympanic temperature, which is really a good temperature because it's very close to the hypothalamus. However, the challenge with this kind of a device is keeping it in the cow. We used this system for a while here at the University of Kentucky and eventually had to give up because we couldn't keep the cows keeping it in their ears. There's also a system that's out now, mainly used for horses, but it's called the VetCheck. And the VetCheck system, it measures respiration rate, blood pressure, and heart rate. And then we have a system like the SmackStec bolus there, representative of multiple boluses that are out there now that measure rumen pH. Rumen pH can be a very powerful tool for monitoring ruminal acidosis. One of the challenges, though, with this kind of technology is what we call sensor drift. This technology may be measuring pH today, but if we go back and look at it 2 or 3 weeks from now, the pH may not be the same measurement that it was before because we don't have the ability to go into that cow, recoup that device, and calibrate it each time, each day. There are also multiple technologies on the market for measuring line behavior. Line behavior, I think, is a very useful tool for on-farm evaluation of line time. It can provide us an identification of cows that require some attention, whether that be lameness, illness, or estrus. It can be a good way to assess facility function or cow comfort, and it can be a potential metric used to monitor animal well-being. Then we have real-time location systems. These systems are basically GPS systems for cows. With these systems, we're using something called triangulation, which is identifying the strength of signal from the tag on the cow to 3 points around it, and using the strength of signal to each point to identify where that animal is. Now, I think these technologies could be very interesting from a day-to-day management perspective because I think these technologies will provide us some valuable information in seeing how the animal changes pattern of where they spend their day, which may be an indication that they are sick or in heat. But I also think that these technologies are really potentially very useful and very exciting for being able to look at the cow's response to her physical environment. Being able to use this information to better understand where cows spend their time, when they spend their time there, and using that to better design facilities and better to determine when we could make some microenvironment changes. So, if, for example, we may find that animals in one particular group are more heat stressed than the other, and we may need to give them supplemental cooling more than what we need to give the other animals. There are also quite a few devices on the market now for calving detection. One of the ways that we can do this is with a probe that goes into the vagina, and these probes measure temperature. There's actually a huge drop in temperature about 24 to 48 hours before calving. So that drop in temperature is used to identify approximate calving time. There are also a couple of newer monitors on the market that are using a tail-based approach. It's basically like a wristwatch that goes around the tail, and this system is monitoring for tail rising behavior. So as the cow gets closer to parturition, she starts raising her tail more, and this technology is going to pick up on that behavior. We've also worked here at the University of Kentucky on developing some new technologies. One area that we've worked quite a bit in is the use of 3D body condition scoring automation, basically using an image analysis, a camera here. In this case, it's the Kinect camera, which is actually the same camera that's used in the Xbox. And we're taking a 3D image of the cow, we're taking that from above, and looking at the contours around the hooks, around the pins, and around the tail head to identify deposition of fat to give us an indication of body condition score. De Laval also now has a system being commercially marketed to do this. We've also played around a little bit with the idea of measuring feed intake using image analysis. So here you can see multiple feed bins. One of them in the top middle is completely full. The others have some feed missing from them. And what we did with that was we were able to identify the change in volume based on the contour of the feed, and that would be an indication of feed intake. We've also looked a little bit at sleep. There's not a lot of work that's been done on sleep in dairy cattle, but it's something we've become interested in as we've seen more of our herds move to loose housing systems instead of stall-based systems. And we've seen those animals sleeping more than what we thought we had seen before. We know the importance of sleep in humans. We know that it helps with immune function. We know it helps with our well-being. We know it helps us resist disease. But potentially, we could use this information for the same things, along with building a better barn for the cow, if we understand rest quality through monitoring of sleep instead of just rest quantity. And the study that we did was a proof of concept study, and we found that 92 to 93% of our observations agreed with human observations for when the cow was actually sleeping. We have worked with multiple technologies for validating them. There was a particular study that Matthew Borchers did where we used 5 different technologies on the same set of cows and monitored multiple parameters from those technologies. You can see here from the line time analysis that our correlations were 1, meaning there was a perfect correlation between the tags, indication of line behavior, and when our observers indicated that the cows were lying down. We've also looked at a couple of different feeding behavior monitors, and in both those cases, those were very good results, indicating that we predicted a high percentage of the variation in feeding behavior relative to our visual observations. Rumination time was not quite as good for one of the technologies, however, was quite good for the other technology. As I mentioned, we've looked some at rumen pH. In fact, I think we've worked with 4 different rumen pH boluses now. Here's an example of what we see. One of the challenges is, you can see in the blue bars, these are the probe measures where we put the probe and measure the rumen fluid pH, and the red indicates the bolus pH. And there are some significant differences there between them. I think part of what's going on here is that the system is just underestimating pH, and that's something that can be relatively easily corrected for, but gives us a little bit of doubt maybe about what's going on with the rumen pH. The other thing is we don't know exactly where that rumen pH resides, where that rumen bolus resides within the animal. It could have something to do with where the bolus is sitting compared to where the pH sample was taken out of the animal. But this is probably the biggest concern we see with rumen pH monitors. On the y-axis here on the graph, you see this is the difference between the probe and the bolus. And in the beginning, the 2 were very close, but across time, we start seeing more of a difference between the probe and the bolus, indicating that sensor does drift across time. On the other hand, we were able to use this technology in an acidosis challenge. In this particular case, we challenge these animals with acidosis, basically giving them a lot of grain. And you can see that our monitor did pick up a significant difference in rumen pH on the day of the challenge, showing that we can potentially pick up acidosis with this kind of technology. We've also worked a lot with estrous detection technologies. This was an interesting study that Lauren Mayo, one of my graduate students, conducted here, where we looked at multiple devices on the same animals. We synchronized these cows, and on the last shot, we skipped the last GnRH shot, allowing them to come into a natural heat. And we monitored the cows 4 times a day, 30 minutes each, where we were doing nothing but visual observation of estrus. The interesting thing here from this slide is that across the technologies, there aren't any real differences in the ability of these technologies to detect the cows that were in heat. The third one from the left was a little bit worse. However, that's not one that's available in the United States today. So all these technologies did a really nice job of identifying when the cow was in heat. And the other thing that was neat was that they all indicated that she was in heat over 20 to 30% more times than what we did. So these technologies are better than humans at picking up cows that are in heat. Another study we did, from my understanding, you guys probably don't do quite as much synchronization as what we do here, but we compared 2 different sets of herds, 3 herds, where we had half the cows go on to a synchronization protocol, a G7G protocol, which if you don't know is a very aggressive protocol. And the other half of the cows, we use an activity management system to know when to breed those cows. And the results were quite interesting. What we found was that there really weren't any differences for most of our reproductive parameters at the end of the study, which would have been toward the middle of lactation. So in this case, we can see that there are no differences between proportion of the cows pregnant at the study. There were no differences in days open, pregnancy loss, services per conception, or service conception rate. However, there were two significant differences. For the timed AI system, the synchronization program, you can see that there was a lower days to first service for the timed AI system. This makes sense. We are intentionally waiting and breeding everybody on a specific day in milk. The opposite of that is the service interval, and you can see in this case the advantage goes the other way. The activity management system has an advantage for the service interval. These cows, we don't have to wait for another pregnancy check to know when to breed them again. So between the two factors there that are different, they essentially watch each other out, and we end up in the same place, whether we use the synchronization program or the activity management system. We've also worked a lot with disease status. So we've worked with monitoring multiple diseases simultaneously. This is some work from Amanda Stone, one of my graduate students here, where we looked at the changes that occurred around mastitis. With mastitis, we saw about 110 decrease in minutes per day ruminating. We saw an 81 difference in neck activity, a 5 kilo or 10 liter, or 10 pound difference in milk yield, and a half-degree difference in reticular rumen temperature. So all these were significant predictors of mastitis. I will warn you, however, that when we ask the question the other way, if we have the alerts, how useful are they, we may not see quite as good a results there. This is a graph demonstrating the pattern of fat-protein ratio in two groups of cows. The group in the red were cows that had subclinical ketosis, and the group in the blue were cows that did not have subclinical ketosis. And you can see from this, starting at about day 3, the fat-protein ratio starts increasing dramatically for cows with subclinical ketosis compared to cows that do not have subclinical ketosis. This one really blew me away. You see here we have days in milk on the y-axis and day in milk on the x-axis. The orange line represents cows without subclinical hypocalcemia, and the blue line represents cows with subclinical hypocalcemia. So in this case, there were over 20 pounds or 10 kilograms difference in milk yield across that period of time. That's a huge economic loss for our farms, not to mention the other effects of these diseases. Here's another example of an exciting possibility. This is the Tracka cow system. It's made by ENGS, another company based in Israel. In this case, we can see that there was almost an hour difference in the amount of time that the cows spent at the feed bunk for cows that were subclinical versus not subclinical hypocalcemia. Of course, we have to talk about the economics. Economics is actually what first got me into this area of precision dairy. I was very interested in the economics of decisions and was looking for a dissertation topic, and this was what I decided I wanted to work on. I really do think that from an economic perspective, with the size of the investment that we're talking about making here, we need to do some investment analysis. We need to do more than this just feels like the right thing to do, or all my neighbors have done it, so I need to do it. These systems are not necessarily one size fits all. What makes sense for one person may not necessarily be what makes sense for another one. It's really most easy to show the economic benefits for heat detection and for reproduction. And I think we can find and agree that systems that measure multiple parameters are the ones that make the most sense. This is an example of the kinds of economic work that we've been doing. This is a dashboard tool that Carmela Dalchek, one of my graduate students, developed. The farm can go in and put their individual farm-specific information, and what they will end up with is a net present value analysis of potential technologies. So you can see this is based on estrous detection. The technology on the right shows to be a positive investment with a break-even time of a little bit over 5 years. The technologies on the left were not break-even, indicating we should not invest in those two particular technologies. And that particular dashboard is available on the internet. So if you're interested in looking at estrus detection for your herd and looking at whether or not you should invest in an estrus detection technology, I encourage you to check out that particular website. Of course, no matter how much we model, there's always an intangible value to having information. This is a picture from a herd that I worked with quite a bit over the years. And this particular day that we were here, the cows were very hot in this barn. And we had some county agricultural agents with us who indicated that they thought that was the case, and they started asking the farmer why. And he said, you know, now that you say that, I've noticed that the cows with the rumen bolus, their temperature in this barn is always a lot higher than for cows that are in the other barn. Why do you think that is? Well, he did not have a ridge vent on his barn to allow air to escape, and he didn't have enough fans in. So we mentioned to him that maybe he should add a ridge vent, and we measured how much wind he was getting with those fans, and we determined he needs more fans. What's the value of that? This farmer actually made those changes. We were out there on a Wednesday. By Monday morning, he had texted me this picture showing me the changes that he made. It's very difficult to model that kind of change. So that's one of the challenges that we have in looking at the economics. I think it's important that we keep a balance between the technological transformation and all of the associated challenges associated with using a technology. You can see here, this is a depiction of what happens with a product across time. We start out with a technology trigger. This is when a new technology comes to market and we start learning about it. We see the ads in our magazines. Then we enter in this period of inflated expectations. We start thinking the technology is going to be able to do more than a technology can do. After that, we enter into a trough of disillusionment. This is basically where we start getting frustrated because we found out the technology doesn't do everything that it was supposed to do, doesn't do everything that we wanted it to do. And after we get out of that, we go into an enlightenment period and a productive period where we actually make these technologies work. It's better than the period where we were disillusioned with the whole deal, but it's also lower than the peak of inflated expectations. To me, this graph puts together very well what oftentimes happens to us with these kinds of technologies. In my mind, with estrus detection technologies, we're on the right. We are actually where we're seeing these estrus detections work well. We know what they can and can't do, and they can be a great tool to add to the operation. On the other hand, I think with many of the health detection technologies that we're still in the peak of inflated expectations. We're still not quite where we need to be with regards to our expectations for how these technologies might work and what their limitations might be. Sometimes these technologies are marketed as plug and play, but maybe they're really more plug and pray or plug and pay. This is an example of our dairy herdsman's office, really not too far from the truth. We have multiple computers, multiple monitors all around that room. Why? Because the technology companies indicate that they do not want their software on another computer with software from another company. It's very difficult to communicate with the herd management information, very difficult to get information out of these technologies. So this is one of our big limitations as an industry is communication of data across multiple platforms. As a dairy producer, I'm not sure I would want to go through 8 or 10 different computers to understand what's going on in my herd today. I'd like to be able to go in and have some kind of an indication that particular day, what's happening on the farm, so that I can better understand how to manage that situation. Another thing we have to be cautious of is that we tend to see this kind of approach to marketing the disease detection technologies. We'll show a picture and we say, look at this cow. She was lying down 6-7 hours a day for a while, and then she started increasing until on the 29th of November, she was actually lying down over 10 hours a day. So what we do is we say we identified this cow had mastitis, therefore the technology should have helped us pick up when this cow had mastitis. And that's good, and it shows some of the potential of these kinds of technologies, but the other side is there are cows that show that kind of spike that had nothing go on, and there are cows that have a almost perfectly straight line for the behavior, and they had a lot of things go wrong. So the sensitivity and the specificity of these technologies is not necessarily very high. So let's bring this to the points of sensitivity and specificity. With sensitivity, basically what we're looking for is how many cows with a condition do we actually find. So if I have 100 estrus events, how many of those estrus events does the technology find? In the example here, I've identified 80 estrus events. But the flip side of that is I've missed 20. Is that good enough? Well, everybody probably would say they want it to be 100%, but that's not realistic. So I would say 80% sensitivity, 20% specificity is actually pretty good. Now the opposite side of that is if I have 100 alerts, how many of those alerts are for cows that actually have something going on with them? So if I have 100 alerts and 90 of them are for cows that are actually in heat, but 10 of them are for cows that are not in heat, is that relevant? Is that what we want to see? I would argue maybe we want to see a little bit higher because the number of alerts that we can see on our alert list every day, if we manage it in this way, can be quite high. This would be a 90% specificity. So the scenario here that we have is an 80% sensitivity with a 90% specificity, and that's pretty good. Now, where we should be depends somewhat on the individual farmer. It also depends on how much they think that they may have in terms of reproductive problems associated with using these technologies more often. We have a lot of questions that we need to think about how we handle the data. What's our protocol for handling alerts? Do we examine cows, treat cows? How do we determine when we don't treat the cows? What do we do about natural reactions of healthy cows? That somatic cell count example that I used earlier. What are we going to do in that situation? I would argue probably the best thing we could do is culture her so that if she does break with clinical mastitis, we're better able to go in and handle it. What are we going to do about repeat alerts? Cows that show up on the alert list every single day. How do we get rid of those? How do we hide those from the farmer for a period of time? What about failed devices? Not something that's talked about very often, but devices do fail. We would say that it would be a good, reasonable goal to assume that we can get 2-3% failure rate within a year, which is great. On the other hand, we've seen technologies that said that they will work for 7 or 8 years, and then they don't work as well. So we have to think about those failed devices. We've seen situations where we may see 10% failure rate per week. I think what we'd like to see is a 2-3% failure rate per year. And what are we going to do if there's a system outage? If I'm relying on this system to monitor my cows for health, to monitor for estrus, then what am I going to do if the system goes out? If lightning strikes, if electricity goes out, we need to have a plan for how we're going to manage our cows in those situations. Then we look at how we can use the data at the group or the cow level. I think this data is most useful for within group changes or within herd changes. It may also be useful for cohort comparisons. When we use this information, we need to keep in mind natural variation and lag. Some of this information lags quite a bit behind. It's not representing what's happening today. It's representing what's happened over the last 2 months. Something like body condition score, for example. And natural variation is there, where we're going to see differences from day to day in things like rumination time or feeding time or grazing time. And we have to be careful not to overreact to a small change in a small period of time. We need to be really careful and cautious comparing information across herds. It's really easy to get caught up in the my rumination time is lower than yours or higher than yours, and say one's better or worse than the other, but it's not really that straightforward. We have to consider production levels of the herd. We have to consider how the tags are attached on one particular herd compared to another. We need to be really careful in doing benchmarking across herds. And we need to question conventional wisdom. We question things that we've heard for years. We hear that if cows lie down more, if cows ruminate more, they'll milk more. And you can see here that there is a positive relationship between milk yield and rumination time, but it's not as strong as what we necessarily would have thought it would be. We can see that there is a decrease in lying time associated with an increase in milk yield. Well, that doesn't make sense. For years, we'd say that if we get our cows to lie down more, they'll milk more. But the thing is, cows that milk more have to eat more. So it's not necessarily the same relationship that we would have thought would necessarily come up. You can see a picture here of my friend David Corbin. David's a dairy farmer here in Kentucky. We worked with David on a lot of different projects. A few years ago, we were getting ready to do a technology project, and I had picked David to be on that particular project. And the technology company indicated to me that I made a big mistake. They said, this guy will never be able to figure out how to use the technology. You picked the wrong guy. He can hardly use a mouse. Well, as it turned out, today, he's super user. He is a pure cow guy. He understands cows, cow behavior, cow husbandry, and he's used data from that system to make him an even better cow manager than what he was before. He's exactly the kind of person that's going to benefit the most from these technologies. People that are looking for it as a replacement for poor management are going to be severely disappointed. You have to understand the cow to get the most value out of these technologies. Certainly mistakes happen, and we've made plenty of them here in our work. Some simple things that we can tend to overlook if we don't think about them. First of all, heat detection systems only catch cows that are in heat. They do not catch cows that are not cycling. If a system picks up a sick cow, she's still a sick cow. We tend to focus sometimes so much on detection that we forget that we're picking up something that's wrong. And so maybe we overcompensate for that, and we focus more on detection than we should and not enough on prevention. If we don't do anything with the information, it was absolutely useless. And sometimes we're the guinea pig. Sometimes we have to go through some growing pains in working with these technologies. We have learned here at the University of Kentucky that Cat5 cable is a raccoon delicacy. Raccoons love to eat cable. They eat cable. They move cable. They unplug things. They are our biggest enemy for keeping our technologies working here at the University of Kentucky. And they say that lightning will not strike the same place twice, but I can assure you it will strike the same technology twice. Lightning is a big problem for us, and it can knock our systems out for weeks at a time. The whole area of precision dairy is still new. We're still learning. We're really at the beginning of this movement. When we use this information, we need to make sure we have a goal for how we're going to use it. Let's don't just collect a bunch of information and figure out what we're going to do with it later. We need to be careful not to jump to conclusions. We can look at trends and draw a conclusion that's not really there. And we need to be careful in not trying to overinterpret that information. And we need to remember that no matter what, some information is just useless. In fact, there's probably more useless information than there is useful information within a technology. These are 6 things that I think people should ask before they invest in a technology. First of all, what's the sensitivity and specificity of the condition of interest? If I'm trying to detect estrous or mastitis, how well does the technology actually do for picking those things up? What percentage of the devices fail in a given year? What's the warranty policy? What's the policy for upgrading to new versions of devices? Making sure we capture all the full costs, the hardware costs, device costs, maintenance costs, and data storage costs. And then making sure that we can get in touch with existing users. It's really important, I think, for farmers to talk to other farmers and trying to understand how these technologies might fit within their operation. I get questions all the time from people asking me, what's the best technology? What's the one that I should invest in? And I will always say the same thing. It's where you can get the best customer service. You want somebody that's going to be able to help you through the installation process, helping you learn how to use the technology, and something that's going to be there for you as you work through problems and challenges with the technology. Where are we going from here? I think we're going to continue to see more sensor-based systems. Over time, I think we'll see more of these that are milk and image-based, and maybe a little bit of a trend away from the wearable technologies. We'll see more technologies focused on animal well-being and environmental impact, maybe even more so than reproduction and health. We'll see more multi-parameter systems, more use of machine learning, things like neural networks and fuzzy logic, helping us better understand how to use the information coming from these technologies. Looking at individual farm algorithms, not assuming that every farm responds exactly the same. We need to adjust these for a specific farm. We'll see more open source hardware, things like the Raspberry Pi, more cloud-based data integration, more user groups, farmers getting together to talk about using the technologies. We'll see more demand for quality alerts and decisions made beyond just it feels like the right thing to do. We look at this area of big data, and I think it's really exciting. It's exciting to think about all the different things that we can measure, all the new ways that we can manage our dairy operations. But at the same point, we need to maintain realistic expectations. Not going to change the world. It's not going to change the whole systems, but it's going to change some of the way that the cows and the people on the operations interact. I sure do appreciate the opportunity to speak to you all this morning. You can see my contact information here. If you have any questions about technologies, please feel free to give me a call, send me an email message. Also, if you're interested in this area, please follow Precision Patty. She's our mascot here. She has multiple social media outlets that she uses for disseminating information that's coming out from the University of Kentucky and all around the world about precision dairy management. Thanks again, and if we have time, I'll be happy to take a few questions.
Thank you, Jeffrey, for such a fantastic insight into this more than exciting topic. I think you have been able to give us a very good overview of all the opportunities and challenges that precision dairy farming can have. I think you've covered a lot of the key items that we've discussed here in Australia, that these are tools, but the key will still be in the management. The manager will still have to be in control of everything. That a lot of these systems provide data, but it's about turning that data into actual information. And I think it's about being realistic about the expectations, because I've seen more than frequently that some farmers have unrealistic expectations of what the technology can deliver. And of course, that ends up not delivering up to those expectations. Well, one of the questions that somebody asked through the chat box was looking at the technologies that are not on the market but that could be coming in the pipeline, and you've covered a bit of that. Trying to look a bit ahead, what do you think might be a truly disruptive technology solution that might transform dairy farming? So it's thinking ahead and not being constrained by current technology availability, but it's thinking more broader of what things maybe are not here today but could come in the future.
That's a good question. It's hard to predict the future, and I certainly don't have a very good crystal ball for that. For me, if there were something that could measure intake, then that would be transformative. And I think whether that's a confinement-based system or a pasture-based system, it's the same challenge. And I don't think there's a great way to do that in either system that I'm aware of right now, but that would be transformative.
Do you think we are far away of being able to estimate intake at a cow level?
In a practical, affordable way on a confinement operation, I know we're far away. And I'm not as familiar with the pasture-based options, but from my understanding, there's still some challenges there too.
Yeah, associated with that. No, that's a good one. Probably I had one from previous work or discussions that I've had with you, but maybe to share with the audience is How far are we from going from the actual raw data that the sensor can capture to actually delivering information of value for the farmer, and maybe coming up with some solutions or recommendations that the farmer can take given those parameters that are measuring on farm? And the second question would be, technology has been available sorry, for some time already, but we've seen that it hasn't changed dramatically the way farmers take decisions, and that adoption has not been that big. What are a bit of the reasons for slow adoption that you've seen all around the world?
Well, I think one of the challenges with the information is that it has to be something that we can do something about. And with estrous, that's one of the reasons why it's been more widely adopted than other things, because it's quite clear what we need to do when the cow's in heat. And so it's a very dramatic change in whatever we're looking at, behaviorally or physiologically. It occurs over a short period of time, and there's a clear action to take. Unfortunately, when we get into some of the health information, it occurs across time, and it's not as clear what we need to do. And so that makes it a little bit more difficult. So I think that there's a lot of work to be done in figuring out exactly what the best thing to do with the information is. But I think there's also a lot of work that needs to be done in improving the algorithms associated with providing alerts. A lot of the systems now are still based on sort of a simple percentage change or number of standard deviations different from an average. And I think that's a little bit too simplistic for some of the conditions that we're talking about. The other thing that I think that we run into is that sometimes the technology may actually be picking up things that we're not capable of picking up. So we may call it a false positive that the cow wasn't really sick when we went and looked at her, but maybe it's not really a false positive. Maybe it's a subclinical condition that we can't see, or maybe she's a day or two from showing physical signs of what's going on with whatever condition the system's picked up on. And what do we do in that scenario? Should we take an action with that animal or not? It's not so clear what to do in that scenario.
Yeah, that's a very good point. Just for the audience that is listening this webinar, you're coordinating the Big Data Dairy Discovery Conference in the US in November, and related to that topic of integrating data and using analytics tools, do you think there is any value in cloud-based services that integrate data from either multiple sensors at a farm level or multiple sensors across multiple farms? And do you think this is something that will benefit only the farmer, or that will go even across the chain, let's say from the farmer, like when we talk from the paddock to the plate, like connecting the farmer with the consumer, those integrations can help more than the farmer?
I think about it more at the farmer level, but there are potential values for the entire chain, even going back to the consumer. There are some questions that come up with regards to data ownership and data oversight there. I think a lot of farmers, it makes them quite nervous, the idea that consumers would have that information, and I can't say that I completely blame that fear. So that's one of the, there's an opportunity, but also I think we have to be very careful in taking it all the way down the chain.
Excellent. Okay, I don't want to steal any more of your time, Jeffrey. On behalf of everyone here today, I would like to thank you for your time, and I really look forward to hear from you again in the future. So thank you very much for your time and your insights into this very exciting topic.
Thank you for having me. Have a good day.
For more information, I encourage all of you to visit the New South Wales Department of Primary Industries website, where you will be able to access tools and resources about the dairy industry. There is a specific section on robotic milking systems, which includes a lot of information on not only robotic milking, but also precision dairy farming and previous webinars that we've held. This webinar will be available at a later time for access. So once again, thank you very much for joining today, and hope to see you next time.